Blockchain is a popular topic right now, and for very good reason. In this video, we're going to build a very simple blockchain in C# in less than 14 minutes. Let's do it. There's no time to waste, so I'm going to dive right in. All you need is Visual Studio. You can also use VS Code if you're proficient with Code and C#, but I'll just use VS. In Visual Studio, I'm going to create a new console application. I'll name the project Blockchain App. If you name it just Blockchain, it'll create a conflict with one of the model objects with the same name, so keep Blockchain App. Once it loads, okay, I'm going to create a folder named Code. I'll add 3 model objects to the code folder. First, transaction. This will just be a simple class for us to add data to the blocks. Next is block. And finally, blockchain. I'm going to start with the transaction class and then just add a few properties. A GUID ID, date time transaction date, a decimal transaction amount, and string memo. Now let's move to the block. This will have an int index to track its location in the chain, then a date time timestamp, then string hash, string data, string previous hash, and int nonce. Nonce, if you don't already know, translates to number used once. Next, the constructor. We're going to require the index, timestamp, data, and previous hash to be passed in. And for each of those, we'll just assign them to our locals. We should also assign a value to hash. It's kind of a weird situation, but we need hash to not be empty. In a second, we're going to create a method named calculateHash, and that's what we're going to assign to the hash property. Okay, calculateHash. We need an SHA-256 instance and set it to SHA-256.create. Next, we're going to create a byte array to store the value of data. The string can literally be almost anything you want. It just has to be consistent. In this instance, I'll set it to encoding.ascii.getBytes, and we want the value of index-timestamp-data-previous hash-nonce. And then we need another byte array named output bytes to store the results of the SHA-256 hash of input bytes. And finally, we'll return a base 64 string of the output bytes. Now we come to the root of it. We need a way to mine new blocks. This is what Bitcoin miners do. The blockchain is going to be set up so that it requires an X number of leading zeros in the hash value. And X is represented by the difficulty parameter. So after the hash is created and turned into the base 64 string, it'll be examined, and if the first X number of digits are not zeros, we'll look for another value. While this is a little bit simplistic, this is really what Bitcoin miners do. They're looking for the next correct nonce. When the hash doesn't have 2 leading zeros, it'll increment the nonce and check it and keep going until it finds a good value. The last thing here is to add a reference to system.security.cryptography for SHA-256. Now for the blockchain. We need 2 different variables. We need a list of blocks for the chain, and we need an int for the difficulty. The constructor is simple enough. We just need the difficulty passed in. We can set that to our local and initialize a chain. And finally, we need to create the genesis block. Every block that we add through the normal process makes a reference to previous block. So the Genesis block becomes the ancestor of every other block that we add. I'll name the new method add Genesis block, and it'll just add it directly to the chain. Index of 0, timestamp value will be datetime.now. The data will just be the string Genesis underscore block, and the previous hash will be an empty string since there isn't a previous block. We're getting close. We need an easy way to return the last added block so that we can get the previous hash. This method named getLatestBlock will do that for us. And we can just return the block at chain.count -1. The next new method will not have a return type and will be named addBlock and just accept a single argument of block. When we get a new block, we need to set its previous hash to the value of getLatestBlock.hash. Then we need to mine the block's nonce with block.mine block and pass in difficulty. Then we can add it to the chain. Just one more method. We need to be able to validate that the blockchain is valid. This method will return a bool and be named isChainValid. And all we have to do is loop through each block in the chain besides the Genesis block and make sure that the value of previous hash matches the hash of the previous block. This loop will start at 1 instead of 0 to skip the Genesis block. We need to get the block at the index of I for the current block. We also need the previous block, which will be I -1. Also, we aren't going to just trust blindly what we get. For each block, we're going to do our own work. We will make sure that the value stored for the current block .hash matches current block .calculate hash. And if they don't match, we return false. We also need to make sure that the current block .previous hash matches previous block .hash. And if they don't, we will also return false. If both tests pass, we can just return true. If you are enjoying the video, please click the like button. You can't believe how much it helps. If you want more content like this, subscribe to the channel. We upload a new video every other Sunday covering topics relevant to software engineers and architects. Now over to program.cs. We need some sample data to pass into the blocks. I'll just create 3 transactions and assign some sample data to them. If you're typing this out manually, just provide your own sample data. It doesn't need to match mine. Next, we'll initialize the blockchain and set the difficulty to 2. Don't go too high here or you'll be waiting for a long time for new blocks to be mined. Next, we'll loop through the transactions. We have to do a couple of things here. First, we need to serialize the transaction to a string value. I'll use Newtonsoft's JSON convert.serialize object and pass in the transaction. Then I'll do a console.writeLine adding block and then the data. Next, we need to create a new block named block and pass in blockchain.getLatestBlock.index +1 for the index. The timestamp will be datetime.now. The data will be JSON convert.serialize object transaction. And last, the previous hash will be blockchain.getLatestBlock.hash. Then we just add it to the chain. That's pretty much it. Next, let's console.writeLine checking if blockchain is valid, and then blockchain.isChainValid. Also, let's console.writeLine blockchain and JSON convert.serialize object blockchain. And set the formatting to formatting.indented. That's all there is to it. Oh, I guess I need to fix the references. I need to install the latest version of Newtonsoft and add a reference to the code namespace. I think that's it. Some housekeeping. I'm going to remove this reference to JSON convert on line 42 and just pass in the data that I already have. Also, the transaction class, all the modifiers in this file need to be public or they won't serialize correctly. This is the easiest way to fix that. I think that's it. Let's test. I have a breakpoint set on line 34 so that we can walk through the most important parts. Unfortunately, if I use F10, it kills my screen recording, so I have to step manually. Stepping through the loop, data looks like what I would expect. And then we create the block, step, step, step. And the properties are set. Then we have to get the hash. Even though the nonce hasn't been set yet, we need a value before we mine. Let's step into the calculate hash method. Step, 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 step. Everything looks normal. Now, look at the hash value. No leading zeros, but it doesn't matter. The leading zeros are only taken into account during the mining process. All right, let's step into the add block method. So it gets the previous hash. Crap, I wanted to step into mine block. We'll go through it on the next one. I'll just set a breakpoint on 34 and keep stepping. Okay, that's the first pass. I want to look at mine block, so I'll just run until it hits. Okay, mine block. Leading zeros is correct. This while loop is going to run until the hash created from the calculate hash method starts with 2 leading zeros. You can see on line 42 that each pass increases the nonce by 1. I'm going to set a breakpoint on 45 and just let the while loop do its work. And your numbers won't match. Your nonce is going to be different. Okay, I want to run it again and do a little validation this time. Create the blockchain, loop through the transactions, step into add block, step out, I'm going to set a breakpoint on 46. Step, step, step. We want the mine block method again. Oh, see, this time the nonce is 10,212. And this time it's only 5238. Now for the validation. Let's watch the blockchain and see what's inside. So I'll expand block 1 and block 2. We can look for the correct values. Block 2's previous hash starts with 00T6 ESBV. And that matches block 1's hash. And block 3's previous hash is 00A6 plus CWB, which matches block 1's hash. Nice. And you can see that the nonce for each is not something that you could have predicted. 5238, 10,212, and 691. And that's it, we're done. I hope you enjoyed this video. It's the first actual coding tutorial on this channel. Hopefully you got something out of it. If you enjoyed this video, try this one, which tells you why all programmers, regardless of skill level, should make use of personal projects. Until next time, keep coding.